In this video, we are starting section 1.4 on predicates and quantifiers. Our goals are to define what are called propositional functions and what are called quantifiers. So these will let us describe things like the statement for all or the statement there exists. Then we'll talk about how to determine the scope of a quantifier. And then finally, we'll convert English sentences into logical statements using these quantifiers. Okay, so in this video, we are going to discuss what are called propositional functions. So we've seen statements like, w is less than 5, or x squared plus y squared equals z squared, things that have variables like this. And these are not propositions because a proposition is either true or false, but not both. And, currently when we look at both of these statements, they could be true, they could be false, but we don't have enough information to determine which of those it is, because we don't have information about these variables to definitively know one way or the other what it is. So I'm going to introduce some notation. I'm going to let P of W represent W is less than 5. And once I specify a value for W, this will become a proposition. So for example, when I look at P of 3, well, P of 3 is representing the statement 3 is less than 5, and well, that's true. That is a true statement, so this is equivalent to true. P of 6 would be 6 is less than 5, but that's not true, that's false. Okay, so this thing, P of W, is what we refer to as a propositional function. It itself is not a proposition, like W is less than 5 is not a proposition, but once we specify a value for the W, for the variable, it does become a proposition, and we call that a propositional function. All right, let's look at another example. I'm going to let R of x, y, z be the propositional function x squared plus y squared equals z squared. Let's evaluate the truth values of the following two things. So first I have R of 1, 2, 3. So if I plug those in, 1 for the x, 2 for the y, 3 for the z, if I plug those in to this expression, to this propositional function, what I get is 1 squared plus 2 squared equals 3 squared. So that's become 1 plus 4, which is 5 on the left, equals 9 on the right, but that's false. That's not true. That is a false proposition. Okay, what about if I plug 3, 4, and 5 in? Well, then I get 3 squared plus 4 squared equals 5 squared. Okay, I'm going to separate these. 3 squared is 9 plus 16. So 9 plus 16, that's 25. And 5 squared is 25, so, okay, this time it is true. So this is a true statement now. So in the next video, we'll show another way that we can take these propositional functions and convert them into propositions by specifying some information about the W, about the variables.